Okay, this is true of bond prices. This is handy to remember. The easiest way to remember this is to remember the middle one, right? If the interest rate, by rate I mean the prevailing rate of interest, the rate that investors want to earn. If the rate is equal to the coupon rate, then the price is equal to par. So I think we've got an example here where we talk about that. So yes, a 10-year 10% coupon bond has a par value of 1,000 and rates are 10%. What is the price? Well, the answer is 1,000. Okay, so if the coupon rate and the interest rate, the official finance term here would be the discount rate, all right, the rate we're going to put in as I in the calculator. If those are the same, then the bond sells for par. And it's pretty easy to see that because if I can earn 10% at the bank, well then when I put $1,000 in the bank and earn 10% on it, that's going to pay me $100 in interest. Well, that's exactly what the coupon bond will do. It pays 10% coupon, which 10% times 1,000 is $100. So the investments are equivalent. The price would be the same, right? So it's kind of handy to remember, though. It'll save you some time in doing some calculations. If the rate is equal to the coupon rate, the price is equal to par. Okay. Now, obviously, if the rate goes up, here, if the rate is greater than the coupon rate, then the price is going to go below par for the reasons we talked about before. When rates go up, the price of that bond goes down because its payments stay the same. And vice versa, when rates go down, if the rate falls below the coupon rate, the price will be greater than par. All right. So yes, here's an example. If rates go up 12%, how does the price relate to par? Well, it's equal to par at 10%. If the rate goes higher than that, then the price is going to be less than par. Okay, so let's talk about interest rate risk. I should have put an animation on this. Obviously, we're taking on some risk here and it doesn't turn out very well. Suppose we buy a 10-year 7% coupon bond today when rates are 9%. And then we have to figure out how much we would pay for the bond. Well, that's just a calculator problem here. We know that N is 10. Remember, the 7% coupon tells us the payment. So I can put in 70. The future value is 1,000. Rates are 9%, so that goes in as I. I think I got everything in there. I compute the price, and there's the price, $871.65. Hopefully that's what's on the slide. There we go, $871.65. Suppose you buy the bond in the morning. Later in the day, I decide to sell the bond. Now you should ask yourself, well, if something has happened to interest rates, which way do I hope rates went? So I bought it in the morning. I'm going to sell it in the afternoon. If rates went up, I'm going to sell it for a lower price. So I'm kind of hoping rates went down. Then I'd sell it for a higher price. And let's see, rates have gone up to 10%, hence the sad face here. Okay, I'm going to be selling that at a lower price since rates went up during the day. And we can see what price I would sell it for. N is still 10 and the payment doesn't change. So 70 payment and $1,000 future value, but now the rate is 10. And if I compute that price, that's $815. Notice it's considerably less than what I paid for it in the morning. Okay, I have that here, $815.61. Now we can calculate that rate of return, right? During the day, just one day, I bought it in the morning, sold in the afternoon. So remember, it's the money you end up with divided by the money you had to pay minus 1, and it's not surprising it's negative, minus 6.42%. All right, so that would be our one-day rate of return on owning that bond. Buy in the morning, sell in the afternoon, very short term. Okay, and then I guess rates went down in this case. We have a happy face. Let's see. Suppose instead of going up, rates went down. So I'm going to sell at a higher price, and I can, again, figure that out here. I'll do it again just for clarity here. Repetition makes things easy. So N is 10. Now rates are 8. So put in 8 for I. 70 is still the payment. And $1,000 future value. And compute the price. And $932.90. And now if I calculate that rate of return, so I'll take the money I ended up with divided by the cost at the beginning minus 1, that's 7.03%. So that's a fantastic return in just one day. If you could earn 7% a day, you wouldn't need very many days in a row like that, and you could just retire. So 7% in one day is a very nice return. Okay, here's one for you to practice. So I encourage you to stop the recording, practice, see that you can get this answer. I'll show you the answer here. So let's see, in this example, I've told you the price that you paid yesterday, and then rates are 7% today, and you're going to sell the bond. So, and I'm asking you your one-day rate of return. So today, let's see, now I'm going to put in 14 for N. Occasionally I have students say, well, yeah, but it's one day later. Isn't that like 13.9 something? And technically you're correct, but in this academic example, we're just going to say it's close enough, all right? Just one day is not enough to change that N, right? If that really bugs you, well, make it 1 hour. You bought it, and then an hour later you're going to sell it. Right, so the time period is short enough here that we don't have to worry about that the change in N is so insignificant it doesn't matter, okay? So N is 14, I is 7 when I sell the bond, and then let's see, the payment is going to be 60 because it's a 6% coupon bond. 6% times 1,000 is 60. It goes in for the payment. Future value is 1,000. And I can calculate that price, and that's $912.55 basically. Now what I'm going to do is I'm going to change the sign of that and put it in memory so that I can remember it. Actually, probably could have just left it there, because what I need to do, this is the money I end up with. I'm going to divide by the cost of the bond, so divided by 984.64. and subtract 1, and that gives me minus 7.32%. So B is the answer here. Okay? All right, so I'll stop here. I'll pick up with yield to maturity on the next recording.